In section 3, we are going to talk about applications of systems of equations, which means word problems. So in section 2, we just reviewed if you have a system, how you solve it. But now we're going to talk about how do I create a system of equations based on information I'm given and then solve for our variables. So it's basically a 3-step process. First, you need to identify your variables. So if you're not sure what your variables are representing, it makes it a little bit more difficult to create your system. Then you're going to create your 2 equations. And lastly, you're going to solve. Now, we're going to mainly solve with either substitution or elimination. We're not really going to solve by graphing here, mainly because you are not required to use the variables x and y when you do a word problem. And also because you get to pick your variables, that also affects, maybe someone picked x to be 1 and someone else chose it to be the other. So we don't really use graphing here. We only use our algebraic methods. All right, so for our first example, we have that Jim needs 320 feet of fence to enclose a rectangular lot. The length of the lot is 40 feet more than the width. What are the dimensions of the lot? So if you remember back when we were talking about area and perimeter, if you have a rectangle, the perimeter is 2 times the length plus 2 times the width. And we know our perimeter. So we know that 320 has to equal 2 times the length plus 2 times the width. We also know the length in terms of the width. We know the length is 40 more than the width. So more than does represent addition. So our length is 40 plus W. Now I get to decide between substitution and elimination. So because one of my variables is already solved for, L equals 40 plus W, I'm going to plug that in for L in my first equation. So we're going to have 320 equals 2 times 40 plus W plus 2W. So now we're going to distribute. So we get 320 equals 80 plus 2W plus 2W. Combine like terms. So we get 80 plus 4W. And now we're going to solve. So subtract 80 from both sides. We get 240 equals 4W. Divide by 4, and we get that our width is 60, and in this case my units are feet. Now I just need to find my length. The nice thing is I know my length is 40 more than my width, so I do 40 plus 60, which means my length is 100 feet. So for my dimensions, it is 100 feet by 60 feet. And when you have a system of equations word problem, you're going to want to make sure your final answer contains units, which is going to be dependent on what your situation is. Okay. So our second example says 2 trains leave Tulsa, one going north and one going south. After 4 hours, they are 376 miles apart. If one train is traveling 10 miles faster than the other, what is the speed of both trains? So there is this formula that exists in science that tells us that the distance you travel is directly related to the rate at which you're traveling times the time it takes you to travel, which is what we're going to be using for this situation. So it doesn't specify when we're looking at our equation which train is traveling faster, so I will get to pick here. So I'm going to let X equal the northbound train, so the train going north, and I'm going to let Y equal the south train. So for my first example, we know that the time that has elapsed is 4 hours and the distance is 376. So we're going to have 4x plus 4y equals 376. And I guess this technically is speed. Okay. For my second equation, since I know one train is traveling 10 miles faster, I'm going to pick just my north train. So that means x equals 10 plus y. So this is another example that is set up pretty easily for substitution. I can take this 10 plus y, substitute it in for x in my other equation. So we get 4 times 10 plus y plus 4y equals 376. So distributing, we get 40 plus 4y plus 4y equals 376, which becomes 40 plus 8y equals 376. So now we are going to subtract 40 from both sides. We get 8y equals 336. We're going to divide by 8, and we get that y equals 42. And then it does tell us that our distance is in miles and our time is in hours, so that means miles per hour. So to solve for my other train, it's going to be going 10 miles per hour faster, so we do 10 plus 42, and we get that x is 52 miles per hour. And that's going to be our answer. In our third example, we have that a group of neighbors went to a play. There were 10 more adults than children with a total paid admission of $620. If the adults paid $12 and the children paid $8, how many adults and children went to the play? So I'm going to let A be the adults and C be the children. So when I'm setting up this system, anytime I have money, that's going to go together for an equation. So I know it's $12 per adult plus $8 per child gives us the total cost spent, $620. We also know that the number of adults is 10 more than the number of children. So A equals 10 plus C. So again, we have an equation where I can use substitution. The 10 plus C, I'm going to substitute into the first equation for A. So we get 12 times 10 plus C plus 8C equals 620. So we'll distribute. We get 120 plus 12C plus 8C equals 620, which becomes 120 plus 20C equals 620. So now we subtract 120. We get 20C equals 500. Then we'll divide by 20. And we get that C is 25 children. So for our adults, we know there were 10 more adults than children, so 10 plus 25, which means our adults is 35 adults. Last example, we have that a fourth grade class contributed $17.70 in dimes and quarters to the Red Cross. In all, there were 96 coins. Find the number of dimes and quarters that the children contributed to the Red Cross. So I'm going to let D equal my number of dimes and Q equal my number of quarters. In a problem like this, I'm not going to explicitly state how much a dime and how much a quarter is worth, because that is something that I expect you to know. So when it comes to my equation dealing with money, dimes are worth 10 cents, so 0.10D, plus quarters are worth 25 cents, so 0.25Q. has to equal the total amount of money, $17.70. For my second equation, we know there were a total of 96 coins. So the number of dimes plus the number of quarters equals 96. In this case, I'm going to use elimination to solve. I could use substitution here, but then I have to deal with a lot of decimals, and if I use elimination, I don't have to deal with decimals as much. So when I'm trying to decide which variable to eliminate, it really doesn't matter here. Because my one equation is just 1D and 1Q, I can pick which variable to eliminate. I'm going to go ahead and eliminate D first. So in order to make the D's have the same coefficient, I do have to multiply by 0.10, but they also have to have an opposite sign. So I'm going to multiply my second equation by negative 0.10. So my first equation stays the same. My second equation becomes negative 0.10d minus 0.25q equals negative 9.6. So we're going to add the equations together. The q's are going to cancel. Sorry. That should say 0.10q. The d's are going to cancel. Then you have 0.25 plus negative 0.10, which gives us 0.15q equals, and then we'll do 1770 minus 9.6, and we'll get 8.10, which we're now going to divide by 0.15, and we get that q is 54 quarters. And I am not going to have your answer for a variable be a decimal. So if you're ever solving a system of equations word problem and you get a decimal for an answer, look back through your work to see if you can identify your mistake, because I'm not going to have decimal answers. Now to solve for my number of dimes, we know dimes plus quarters, so D plus 54 has to equal 96. So we subtract 54, and we get that we have 42 dimes. Let me know if you have any questions on identifying variables for a system of equations word problem, setting up the system of equations, which I do believe is the hardest part of a system of equations word problem, is figuring out what is my system, and then if you have questions about substitution or elimination.